Hey everyone, moving on with our properties of complex numbers, mainly the algebraic properties of complex numbers. So I'll start off with letting z be a plus bi. Alright, so this will be the main complex number we'll be talking about. So the first property is actually more of a notation. If you see z asterisk, this is actually called z conjugate. So what is a conjugate? In complex number, conjugate basically means that you have the same real portion, a, but your imaginary portion is flipped. So a plus bi becomes a minus bi in z conjugate. Or likewise, if I have w equals to c minus di, then w conjugate, same real, flipped, imaginary plus di. Alright, so that is the first notation that you need to know. Other than that, the second one is we know that I equals to root minus 1. I square is minus 1, not what you think it is. Not, okay, you might think, well, I'm going to do this. Oh, hey, you know the property of root a root b equals to root ab? Minus 1 times minus 1 is 1. Then I get back 1. No, this is not true. It doesn't work because these two are not real numbers at all. Therefore, the properties of real numbers of root a times root b equals to root ab does not apply here. Alright? So in a sense, this is wrong. So root minus 1 times root minus 1 gives you back minus 1. Alright, so take note of that. Then from I square we have I cube, which is, well, minus 1 of root minus 1. You can probably guess it. Root minus 1 minus I. Lastly, I power 4. Well, minus I times I equals to minus 1 times minus 1. Now it then becomes 1. Alright, so this is the powers of I. Then of course you realize that, hey, it kind of rotates, or rather it goes in a cycle, right? So from here you get I power 5 is the same as I power 6 equals to I square and all that nonsense. Alright. Now, other than that, the third property that you need to know is actually sort of a feature of complex numbers. It's called the modulus of z. Simply the modulus sign. So modulus sign of z, or modulus of z, is simply the magnitude or the length of a complex number. Alright, but we don't really say the length of a complex number, we say the magnitude of a complex number. So it's exactly the same as how you would calculate the length between 2 points. Alright, simply we know that in the Argand diagram, you know that let's say a complex number on this side, this is the magnitude. Alright, or known as r. So this whole length here is the magnitude. Based on Pythagoras theorem, this is y, below is x, this is a right angle, therefore the magnitude is simply a square plus b square root, or the more common way, if you have x plus iy, x root x square plus y square, also known as the square root sum of squares. You don't need to know that. Alright. Now, lastly, what are the complex number properties you need to know? Actually, rather, there's two of them, really. First part is your basic algebra. Alright, if I have a plus bi times c plus di, the whatever method, rainbow method, whatsoever, applies as well. So let's say I have ac plus now bi times c, so bci plus adi. Now, you have to be careful here. Bi times di, you might accidentally write it as plus bd. I square is correct, but don't forget I square is minus 1. So take note of that. Therefore, the faster way really is if you have enough experience, you can kind of do this pretty fast. Just remember that I times I is always negative bd. Alright, you can do it systematically. up to you. I'm not stopping you. Fifth property is the rationalizing the denominator. So sometimes you get a complex number with the denominator having a complex number. So what you need to do, if you want to simplify this, is rationalize the denominator in the normal way, because it's really just like how you rationalize the denominator for a surd of a real number, right? Just remember that I is root minus 1. So if you have root 5, 1 minus root 5, you're going to rationalize it by 1 plus root 5 as well. So it's the same idea right here. That's why if your denominator is a plus bi, you rationalize it with a minus bi. On top, 2a minus 2bi, below a square plus, not minus, b square. Why not minus b square? Because pretty sure you know a square minus bi square, b square times I square is minus b, minus b equals to a square plus b square. Alright, let me just write it out for you so you can see what's going on. Alright, this also then brings me to really sort of a extension to this property. If you notice, if you have z conjugate, right, we have a plus bi times a minus bi. This simply equals to a square plus b square, and you realize it's basically the square of the modulus of z. Alright, so these are the properties you need to know. One, notation, actually two, notation, conjugate, and modulus. The others, the expansions and the rationalizing of denominators. All these skills you probably already have, right? It kind of applies to normal algebra, just be careful with the complex numbers where the i's might pose a little trouble for you. With enough practice, they are really not a threat. Alright, see you guys in the next video.